EACC Math Lesson number 21, Solving a System of Equations Algebraically. Over here in this right corner we have a system of equations. As you can see, we have two equations with two unknowns. This shows up in business applications and all sorts of applications. And what we're doing is we're looking for this simultaneous solution. If we look at it graphically, it's where the graphs cross each other. It's what the point they have in common. That'll give us the solution to both equations at the same time. Now, sometimes the system will not have any solutions if the lines are parallel, and sometimes they'll have an infinite number of solutions if the lines are the same ones. We're not going to concern ourselves with those two other situations today. We're just going to look for this simultaneous solution, and we're going to do it algebraically. Because remember, algebra is weightlifting for the brain. Makes you stronger. Okay, so looking at our first example. Here we have a system. In fact, it's the same system that was on the first page, or first slide. But this time we're going to solve it algebraically. Now, what you want to do is you want to eliminate one of the variables. And the way you do that is by adding the two equations together and making sure that in those two equations you have one positive and one negative of the same number so that those disappear, go to zero. Okay, well, I can see here I already have a positive 2 and a negative 4x. So they're very similar. If I just multiplied this top equation by 2, I'd get a positive 4x up there, and when I add them together, I would get rid of the x's. So that's what we're going to do. So I put parentheses around the equation to remind myself to distribute the 2. So we get 4x minus 6y is equal to 0, and the second equation stays the same. Okay, now we're just going to simply add those two equations together. So 4x plus a negative 4x is 0, so I have no x's. Negative 6y plus 2y is a negative 4y. 0 plus negative 8 is still negative 8. Finish solving for y, then I'm simply going to divide both sides by negative 4, so y is equal to 2. Okay, so we've got one of the variables. To find the other one, you go back up to your original equations. You can use either one. It doesn't matter. Pick the one that looks easiest to use to you. I'm going to use the first one. So I've got 2x minus 3 times y, but now I know that y is 2, so we'll substitute that value in. It is equal to 0. So 2x minus 6 is equal to 0. So 2x is equal to 6. Divide both sides by 2, so x is equal to 3. And we'll write our answers as an ordered pair, the x going first, so my x was 3 and my y is 2. So we found that solution algebraically instead of looking at the graph. Okay, here's a second example. Again, I'm looking for a situation where I have a negative and a positive. That would be nice. Or something easy to work with. Well, if I look here at my x's, they're both 1x. So if one of them was a negative 1x, I could get rid of it pretty easily. So that's what I'm going to do. I'm going to multiply this top equation by negative 1. When I do that, it just simply changes the sign, so I have a negative x, and then plus 2y is equal to negative 14. I'm going to keep the second equation as it is, and now I'm going to add them together. The x's are gone. 2y plus 3y is 5y. Negative 14 plus 9 is a negative 5. Divide both sides by 5, so y is equal to a negative 1. Again, once I have one of the variables, you go back up, pick one of the equations, find the other variable. So I'm just going to use the second equation this time. So I know that x plus 3 times negative 1 is equal to 9. So x minus 3 is equal to 9. So x is equal to 12. Add 3 to each side. And again, we will write our answer as an ordered pair, so x is 12 and y is negative 1. So there's our common solution. All right, my third example. Okay, here it's not real obvious what to use. I could get rid of the x's, I can get rid of the y's. So let's see here. I think I'm going to get rid of the y's this time. And 3 and 4 both go into 12. So I'm going to turn those both into 12. So I'm going to make one negative. So what I'm going to do is I'm going to multiply the top equation by negative 4 and the bottom equation by positive 3. When I do that, I get a negative 16x, a minus 12y is equal to 4, and a positive 15x and a plus 12y is equal to 3. Okay, adding these two equations together, negative 16 plus positive 15 is a negative 1x. The y's are gone, which we want. 4 plus 3 is 7, so that means that x is equal to a negative 7. Again, go back up, use one of the original equations. It doesn't matter which one. I'm going to use the first one this time. So I have 4 times negative 7 plus 3y. When is that equal to negative 1? So negative 28 plus 3y equals negative 1. Add 28 to each side, so 3y is equal to 27. Divide both sides by 3, so y is equal to 9. Again, writing my answer as an ordered pair, x is 7 and y is 9. Okay. Fourth example, here we have the situation where the equations are not in the same form. So we need to get them in the same form. So I want to get my x and y's on the same side. So I'm going to use this second equation. I'm going to add 3y to each side. So I'm going to leave the first equation alone. Adding 3y, now this equation looks like this. 2x plus 3y is equal to 12. Okay, so now I have them in the same form. Okay, this time I think I'll get rid of the y's. I'm going to multiply the top one by 3. You know, when you're doing this, it really doesn't matter which variable you decide to get rid of first. It does not matter. As long as you do all the arithmetic correctly, you'll be fine. Okay, so then my new equations look like this. I have 12x minus 3y is equal to 30, and 2x plus 3y is equal to 12. Adding these together, 14x, the y's are gone, is equal to 42. So that tells me that x is equal to 3, dividing 42 by 14. All right, once I have my x, I'm going to go back up to one of the original equations. I'm just going to use this first one here. So I know that 4 times 3, take away y, is equal to 10. So 12 minus y is equal to 10. So negative y is equal to a negative 2. So that means that y is equal to positive 2. Divide both sides by negative 1. So, again, my answer as an ordered pair, x is 3 and y is 2. Okay, that's the last example. You've got some problems to work on, and again, like always, as we go through this process, if you have any questions or problems, come and see the math guy. Thanks.